Let's learn some shortcuts. I know these are going to be overwhelming at first, but the more you do them, the easier it's going to get. And also, it's so much better than using that definition of a derivative. So we'll get used to it, and the more you practice, the more you will literally not even be able to forget these rules. 10 years from now, I could ask you the derivative of x squared, and you will probably know the answer. They just stick with you after a while. So first thing is the derivative of a constant. So if your original function is just y equals c, it's just some number. The derivative of that, y prime, remember the prime symbol means the derivative, so if the original is y equals c, the derivative of every single constant is 0. Okay? Now let's use our first rule. We have f of x equals 10, so if we want to take the derivative of it, we're going to call it f prime of x. What's the derivative of 10? Well, 10 doesn't have an x in it, it's just a regular number, so its derivative is 0. We just did our first shortcut. Our next rule, or our next example rather, is called f of x as well. So the derivative is going to be called f prime of x, and 2 pi, just a weird looking number. Plug it into your calculator. 2 pi is just a number. The derivative of every single number is 0. So some weird numbers to be on the lookout for. Weird constants that we could come across that we need in math. You could have a pi. Derivative of pi is still just going to be 0 because it's a number. You could have something like e squared. You have an e button on your calculator. The derivative of e squared, that's just a number. It's going to be 0. Or like ln of 2. You could plug that in on your calculator. Ln of something is just a number. The derivative of any number is 0, whether it's 2 pi, e squared, or ln of 2. All of our crazy looking constants, their derivative is 0.